So now we will do a problem on steady flow energy device. So the problem is like this. The air flows steadily at a rate of 0.5 kilogram per second through an air compressor entering at 7 meter per second. So this is not a turbine, this is an air compressor. So for a compressor, let us draw a compressor here. So this is the compressor. So, so air enters here, maybe it enters here and leaves here. See, this is zero 0.5 kilogram per second. So this is a steady flow device. See, this enters at 7 meter per second and 100 kilopascal. Okay, this enters at 7 kilopascal and 100 kilopascal. And the specific volume here is of the air here is 0.95. Okay, 0.95 meter cube per kilogram. It leaves at 5 meter per second, 700 kilopascal and 0.19 meter cube per kilogram. It's the specific volume at the end. Okay. So internal energy of the air leaving is, so this is kilojoule, 90 kilojoule per kilogram greater than that of the air entry. So this is the change in internal energy. And cooling water in the compressor jacket absorbs heat from the air at the rate of 58 kilowatt. Okay, so this compressor releases heat that is absorbed by the cooling water. So heat released is given as 58 kilowatt. So compute the rate of shaft work input to the air in kilowatt. Okay. So you can apply the steady flow energy equation here. So this is Q dot plus M dot into H1 plus V1 square by 2G plus GZ1 is equal to. So this is a steady flow device. So you can apply the steady flow energy device. So let us look at each term. So this Q dot can be found out because this is given as the heat released, that is minus 58 kilowatt. And see, the inlet velocity is given and outlet velocity is given. And this is almost at the same level. It is the height difference is not given, so you can neglect it because this is almost at the same level. And another thing given is see, H1 and H2 is not given. This M dot is given as 0.5 kilogram per second. So if I expand this, you will get this as minus 58 kilowatt plus 0.5 into this H1 can be written as U1 plus flow work P1 V1 plus V1 square by 2G plus G. So this is capital V1. Okay, you can write it like this. So M is 0.5 kilogram per second. So you can neglect this GZ1 and GZ2 because they are almost at the same level and it is not given in the problem. So you can expand it. So P1 V1, that is pressure into specific volume at inlet, this is 100 into 0.95. Okay, 100 into 0.95 into 10 raised to 3. Okay, and P2 V2 is again this is 700 into 0.19 into 10 raised to 3. Okay, so plus, see, this is V square by 2G, this is 5 square by 2G, and here V1 square by 2G is given as inlet velocity is given, that is 7 square by 2G. So W is equal to minus 58 kilowatt plus, so you can solve this. So if you rearrange this, you will get W is equal to minus 58 kilowatt minus 0.5 into U2 minus U1 plus 700 into 0.19 into 10 raised to 3 plus 7 square by 2g minus, yeah, you will get like this. So if you solve this, this u2 minus u1 is given as, so in the question it is given that the internal energy of the air leaving is 90 kilojoule per kilogram greater than that of the air entry. So you can use that information here, that is 90 here, and this is 38 plus 38, you will get it as, finally the answer is minus 122 kilowatt. Okay, this is minus because you are supplying work to a compressor. So compressor is not producing work, it needs an energy work. So work is supplied to the compressor, so it is minus 122. And the second part of the question, find the ratio of the inlet pipe diameter to the outlet pipe diameter. So for that, you can make use of this equation. This is a one-dimensional continuity equation. That means mass flow rate is equal to rho1 A1 V1. Okay, that is, this is the area of cross section, and V1 is the velocity, and rho1 is the density at this location. So that means this is equal to A1 V1. Rho1 is, you can write it as specific volume 1. Okay, 1 by specific volume, because rho is mass by volume, specific volume is volume by mass. This is specific volume. So you can make use of this equation, okay, to solve, find A1 and A2. So A1 by A2 is equal to 3.57. A1 by A2. So A1 by A2 is pi by 4 D1 square by pi by 4 D2 square. So this is the ratio. This is 3.57. Okay, so you can take the root. So d1 by d2 will be root of 3.57. So this is how we solve a problem using the steady flow energy equation. So d1 by d2 will be 1.89.